Thank you very much for everybody that made time to join this webinar, and welcome to the OnSite Technology webinar hosted by SciTech. Firstly, some house rules or housekeeping. If everybody can just keep their cameras off, it's just me and Dave that will have our cameras on. Keep your microphone switched off as well. Any questions, you can put it in the chat. And then at the end of the session, we will have an open mic session where we can ask questions and we can answer.
We try to answer.
Okay, so introductions. I'll be your host today, Jaco Wicher, General Manager at SciTech. And then I've got Dave McNamee. He's the Sales Engineer Manager for the EMEA region. He's joined us all the way from Germany.
Hello.
Okay, so if we can go through the agenda. Firstly, introductions that we've done. We're going to talk about your design. Is your design within specifications? Third-party design direct to the machines. Is it a good idea, bad idea? International Roughness Index, IRI, like you all know it. Then Dave is going to do a short demonstration, and then we'll have an open session where we can ask questions. I think, yeah, I'll hand over to Dave. Dave, thank you very much for joining us. And yeah, over to you.
Hello, it's a pleasure to be here. So I have a strong accent. So if I speak too fast or you don't understand, please put it in the chat and I would slow down and try and explain it a bit more simply for you. Okay. So the idea of today's presentation is to take you through, you get your designs for your roadways or your construction sites, and what type of operations can you do before you actually put into the machine to make sure that your data is correct, is accurate enough, and within your tolerances. Okay, so is your design within the specification? Next, please. So we've got this model that's being created in a third-party design. It was created as cross-section data. Started at regular 20 meters, but in occasions it's actually close together. And it's a land XML. So we bring it into Trimble Business Center. It recognizes that the alignment is there. There's a surface model in there, and there's cross-section data in there. And first look, it looks okay, but we need to investigate a little bit further. If you look at the bottom of the curve in the middle, you can see it's not really a smooth curve. It's more of a chorded arc on here. So that's the first place we really want to look at. So next slide, please. So what we have here is you see that the bright line is the center line, and the blue line, if that's wrong, sorry, I'm colorblind, so it could be yellow and blue or green and blue. We can do a measurement between what the actual true geometry alignment is to where the chorded line is from your cross section. So remember, these are every 20 meters. And if you look at the chainage there on the right hand side, you can see it's chainage 253.7. And at the moment, it's a 49 millimeter difference between what the alignment should be and what the actual cross section is. This is on the horizontal curve. If I do the next slide, please. We again go to the vertical curve. Same idea. We check the alignment, the geometry alignment, which is the nice smooth curve, against the imported cross-section data, which is the chorded arc. And again, you can see its cross-section is 63 millimeters difference between the true geometry and what our imported data is. So there, first of all, there's some errors that you need to investigate. Is that good enough? Is it within my tolerance? Am I happy with that data? If not, then you need to go back to the designer and say, hey, we need to change this, or we need to improve what's going on in this data. However, we have some tools within Trimble Business Center that helps you correct for these errors or makes your data even better. Okay, next slide, please. So we imported that design as it was. We didn't do anything. We accepted those errors and we put them into the machine control system. So on the left-hand side, you can see the screenshots from the operator view in our machine control, and then the visualization from our simulator. And you can see that the curves are not smooth. It's a series of chorded arcs going around the horizontal and the vertical curve, where those errors we saw previously come into it. Okay, so it's not a very smooth model. You have to accept, back a bit. You have to explain, I have to realize and accept, do I accept that model or do I go back and change it? Or do I edit it myself? And the benefit of TBC allows you to go into this data set, tweak some things that I'll show you in the next few slides that allow you to make that tolerance even better. Okay, go to the next slide, please. So, is your slide within specification? At the moment, it might be outside what we've seen earlier. We've got the difference between the horizontal and the vertical from the geometry to the actual chorded arcs. We can do in TBC what we call densification. If we go to the next slide, please. Side by side, on the left, the screen on the left actually shows you the original model that we brought in. We said earlier it looked okay. And on the, after densification on the right, what it looks like now. And you can see there's a lot more templates have been put in on the curves, horizontal curves, and or on the vertical curves. So you're actually on the straight, you see there's no curve in there, but we've got more templates. That indicates there's actually a vertical curve in the alignment, and that's where we put in those extra templates in here. Okay, next slide, please. If you look at the chainage, it's exactly the same chainage as what we had previously, 253.7. And the densification difference now between, or the difference between the actual physical geometry, the alignment, and that chorded arc is 1 millimeter. Okay, so before it was something like 49 millimeters. Now it's only 1 millimeter. So we've actually brought that tolerance in. If you look on the right-hand side, this is the densification option. So when you have a surface model in Trimble Business Center, you have an alignment. You can say this surface model is an alignment-based surface model, and I want to densify it. And the densification has a tolerance. In this case, it's 3 millimeters. So depending on how accurate you want to make your model, what type of machines you're working with, what type of material you're working with, you can say 3 millimeters, 10 millimeters, 15 millimeters, whatever you need. We've also included the val, which is the vertical alignment. So we said yes to that. And that's why you saw those extra templates on the straights. That indicates there's a vertical curve in that area. Once you say that, you can see the densification come through. It'll put in extra templates. If it's too many, if you don't like it, you can actually change that tolerance and say, okay, make it 5 millimeters or 10 millimeters, depending on what your tolerance is. The beauty of the densification, it does not significantly increase the size of the file. It just looks at the model, puts in where your templates are and says, okay, this is where I'm going to work. What it does is it starts on the chorded arc. It moves along that chorded arc and says, okay, how far away is that line from my chorded arc? It's 1 millimeter, it's in tolerance, 2 millimeters in tolerance, 3 millimeters in tolerance, 4 millimeters, it's out of tolerance, puts a new template in and starts again. So that's where the 3 millimeter actually comes from. Okay. Next slide, please. Here's a check, the same location, the same chainage that we had before. Chainage 50, again, 1 millimeter difference. Before it was 63 millimeters. So you can see it significantly improves the accuracy of your model without actually physically changing the model. It just says, okay, I have a true alignment, I have a surface model, please correct the surface model based on the alignment by putting extra templates in that helps us. Next slide, please. Similar as we had before, now you can actually see that the curve of the model, you see the extra templates are put in, so the spacing is less. We have a nice smoother alignment surface created from this densification model. And that is the big, say, benefit of densification, improved quality of surface, but not risking a massive increase in file size. Okay, Next slide, please. Here's another option that I'll explain and actually shows you easier or better how densification works. So again, we've got this cross-section data that we've imported from a third-party software. These are a 20 meter separation. However, if you look on the right-hand view, you see that the actual true geometry has some pretty tight curves on there. You compare that curve to what the actual surface model looks like, you can see 20 meter straights doesn't look very good. Your accuracy is gone, your tolerance is outside of what you're trying to build. How can you build a model or a surface to 5 millimeters, 10 millimeters, when your design is automatically out by 60, 70, even 10 centimeters? Okay, so this is where, again, the densification really shows and comes into its own. If you go to the next slide, please. So I can't see the things here now. We have densified the model, sorry. And you can see now the magenta in the plan view on the left-hand side, the magenta lines is the densified model, and the blue line is the original cross-section. So here you can see really accurately that densification really improves. It keeps the geometry of my alignment and corrects the model by putting extra templates in. On the right-hand side, there it is again in the 3D view. It really truly follows the geometry of your alignment, correcting the model. Now you can safely send this up to the machine, start doing your work, and start excavating within your tolerance. So now you're happy your design is in tolerance before you even start. Okay, next slide, please. A big question that's always been around with Trimble is, I have a land XML file. Why can't I take yours directly to the machine? Well, now you can. Yes, you can in Earthworks. You can take land and X files directly to the machine and start working with it. But is that really what you want to do? You don't want to check that model? And how often have you built or received designs that are not 100% correct every time? Some aren't even finished when you get the designs. They're ongoing designs, changing all the time. So why would you say, take this out, put it into my machine? So I'm just going to show you some examples now. If you go next slide, please. So if you look on we start on the left-hand side. This is what was designed in CAD. In the plan view, it looks fairly okay. There might be a suspicious incident in the red triangle. If we look at that in the 3D view, we actually get a flag in TBC. It says there's something wrong with this data. You've got crossing break lines, and it will give you a value, but it also gives you a big flag to say you need to look in this area to find out where this data is, what's going on. The middle 3D view, that's actually zoomed in onto this area, so you can see there's a spike in the data. If you'd taken that straight into the machine without checking in TBC or other software first of all, you'll see what it looks like in the machine. You've got a big spike, so your model is going to be wrong. The operator doesn't know that. He starts building and he starts putting extra material in where it's not needed. So that's extra material cost, plus the cost of having to go back and correct this and rework this area to make it what it was in the design. So for a simple, quick check, if you go to the next slide, please. Again, CAD 3D, you've got your area of interest. You think, okay, there's something not quite right there. You go into the 3D view, you can rotate it around, and now you can see the break lines. Directly in TBC, in the 3D view, you can identify those errors. You can identify those cross and break lines, and you can correct them by deleting it in the 3D view. You haven't got to go back into the plan view and try and assume which line is the right one, which line is crossing, which line's not. You can see this directly in the 3D view and edit and correct the model. So now you're happy. You have a nice corrected model. You can put that into the machine and be confident that what you put down is going to be right first time. Okay, next slide, please. And there you see there's no spike in the data. Designed smooth, nice smooth slopes, exactly what you need to be for the sake of 30 seconds. Okay, it doesn't, sometimes even 30 seconds is quick, in, out, check it, and send it out. You've saved money by not putting extra material in. You've saved money and time and fuel because you haven't got to send the machine back to go and correct what was wrong. Really good idea. If you want to put the land XML straight into the machine without checking, we can do it. That's no problem. If you want to do it, fine. But we all still recommend that you check the data before you send it out to the machine. Okay, next slide, please. International Roughness Index. Why? Next slide. I'm not going to read all this, but basically the International Roughness Index, or IRI, is how good a road surface that you've made. It's a worldwide regulation. And if you look at the bottom, there's a little table there that actually shows you between IRI in inches per mile or meters per kilometer, what the different classification or road condition is. So anything over 4 is very poor. Anything less than or better than 1 or less than 1 is excellent. So this is where you can run your IRR commands. It will then look at that model, tell you if that model is good, passing your IRI tests. If not, it will show you where the problems are. You can then go back and start investigating further into the design, what is going on. And there's 2 ways we can do this with TBC. We can do this on the model before we actually send it out to be built. And we can also bring that back in. So if you've built a surface, excuse me, and you've gone off and scanned it with mobile mapping or SX12 scanners, or if it's asphalt paver, you can bring those paving files back into TBC. You can then run this IRI command against that as-built data. It will tell you this is where your design was. This is what your IRI is on your material that you've put down. So your design was in tolerance. After the as-built, something's not right, and something has gone wrong and you need to go and check. Ideally, everything will be good. If your IRI of your design is good, then your IRI should be good for your material. Okay, next slide. So how has it worked? It's calculated by using a mathematical model of a vehicle suspension. So it's a quarter car model, and it basically interpolates a car driving down that road and the displacement or how uncomfortable that road is for the car to drive on. It's used for the conditions. So say they can use it for pre-work. So they can go off and scan the surface of the road, come back, do this IRI test and say, right, okay, this road surface is out of tolerance. We need to go and mill it or we need to replace it and then put a new design down on there. So it's not just used for as-built afterwards, it's used to determine if the road surface is within our calculation of good conditions. Okay, next slide, please. So we have a road model. You've seen the model before. We have on the right-hand side, we select the alignment because we need an alignment and we need a surface model. And there's 3 basic types of analysis we can do. We can do continuous, overall, or fixed length. Generally, we recommend that you do the fixed length. That allows you to specify every 10 meters, 20 meters, or depending on how your road has been designed, what that interval can be. You can do it for the whole road. You can do it for a certain chainage between chainage 20 to 60. And you put in your IRI threshold. So using that table from before, you can determine what is your threshold. That comes from your road authority. They say it has to be within 1.4, 1.7, 1.75, whatever. Excuse me. You put that in and then you run that report. So next slide, please. Here it tells you the information of your job site. Segment length is 10 meters. Our IRI threshold is 1.75. Here's our scallop height. So scallops are basically deviations in the road surface made from the machines. and that's what actually has that into that roughness report as well. If you go to the next slide, here it shows you what is going on. So you have your every 10 meters, your start chainage, 150, 160, you get down to 170, you can see your IRI is in red. It's 5.1. Next one's okay, 1.7, okay, 210, out of tolerance. So what you can do is you can then go into that design that you have in your TBC, and you can start investigating that's what's happening at 170 chainage and what's happening at 210 chainage. I'll show you a little bit later on that actually corresponds to the vertical curves. It's the start of the vertical curves. So maybe the design factor in this road for the vertical alignment needs to be changed or need to be altered to bring these IRI values back into tolerance. But this gives you an idea to say, go back and say, okay, something's wrong. In this case, it's quite good because most of them are black, not in red. If all of these are in red, then you definitely need to go back to your design and say, hey, something's wrong with this design. We need to do it. Okay, next slide, please.
Okay, Dave, I'm going to stop sharing, then you can take over the screen. So Dave is going to do a short demonstration for us.
Share. Okay, could you see my screen okay?
Yeah, I can see your screen.
Perfect. So this is TBC. For those that haven't actually ever been into TBC, it can look a bit daunting because you've got all of these menus along the top. But what you can do is you can go into support into here and you can customize the ribbon. And you'll see on here are all the titles for those menus along the top. And you can see there's an eye. If I click on that eye, it removes that menu from the top. So if there's a lot of those menus that you don't really need to use, you can reduce them. You can also customize the commands. So you can really user define what your TBC looks like. So it only has your menus that you use all the time. I don't need to see tunneling. I don't need to see monitoring. That's what I need to do on here. So point clouds, I'm not interested in. Photogrammetry, tunneling, and monitoring. I'll just take them off. And now you see the top line has really come down. There's still a few on there that I might be using, but it's user definable. We also have home, views, CAD, everything in here. And generally when we work, we start at the left-hand side and we work through what's going on. An example here on surfaces, we have Surface Manager, Create Surface, Composite Surface, and then all the tools to run it through here. We have a graphics area. We have a command bar. So you can see at the bottom corner now, I have coordinates. If I click on this icon here, I can bring up my coordinate box, right mouse click, and bring in and assign what I want to see. We also have a project explorer that lists everything that I've done, what I've created, what I've imported, and a view filter manager, which it does exactly what it says. It actually allows you to hide or make visible what you need to have or what you want to have. Import, you can do import. It will import and recognize various file types. Or in this case, I can drag and drop data for what I want to do. So I'm just going to quickly go in and show you that first data, the land XML file. So here we have a land XML file of a proposed road. Drag and drop, bring it in, and it's asking me what type of data is this. It's found point and break line based definition. It's found a triangular based definition, or do you want to import both definitions? If I bring in a point and break line, that allows me to edit the data that comes in, how the surface is formed. If I bring in the triangular-based definition, it does not allow me to edit individual points or break lines to correct or edit that model. Or I could use both and have both. I have the option to have a permanent fixed model that was the design and allow me to change it. In this case, I'm going to bring in as a point and break line. Okay. First of all, you can see you've got the general shape that you saw, but we also have surface model outside where it should be. So we don't want to have all this material in here. So we can actually go to our surfaces menu, and we have an option called Trim Surface Edge. The beauty of TBC, as soon as you put your cursor over command, it actually comes up and tells you this is what the command is going to do. So I go to Trim Surface Edge. It says start out here, come inside, and I will cut those triangles out. You select the surface you want to use. There is only one. Where's my outside point and where's my inside point? So I start outside and I say I want to come all the way in here. Nothing happens. Why has nothing happened? Because if I then go and click on the outside edge, I can see when this was exported, they actually created a break line on the edge of the model, which should not be there. The break line should follow the curve and around this line. So I can actually go into here now, delete that. And now when I go to Trim Surface Edge, outside point, inside point, and you see here we've got some triangles. Because there is a break line fixing the edge of the surface, I can go across and it doesn't delete the triangles inside my model because it knows that break line is the edge on here, and it stops me removing those details. You can also see now there's two flags, and you can see the triangles are actually misshaped, so you can understand straight away what's going on. On the icon bar down here, you see we have an icon for a flag. So if you click on that, that will actually bring up your flags window. We have two warning. Break lines intersecting 1.2 meters and break lines intersect with a difference of 24 millimeters. If I just zoom in a second here and I say, okay, double click on that one, it brings in and shows me the center of the screen where that flag is. So if you had multiple flags here, you could go double click on it and it shows you exactly where that error is. I know that, but at the moment, I'm not really sure which line is the problem. It's a plan view. All the lines look the same. So what I can do is I can go into my 3D view. I can spin my model around and I can move it around. And now I can see in 3D exactly where that problem is. So I click on that line. I can see it's not correct. I simply want to delete that line. That flag's now gone, and I have my surface model. Zoom in into here again, and again you can see we have a break line. So if that was on the plan view, you would have a very hard job of finding out which is the wrong line and which is the one you need to delete. Now our surface model is correct. Everything's looking good. I can then ship that out to my machine. So if I hadn't checked that, within 30 seconds here, put that into the machine, all that region would have been built incorrectly. So it's a very quick, simple way of checking data before you bring it into the machine. I'm just going to create a new default project. And I have another option on here. So we have another XML from a third party. I can bring that in, and just like before, it actually shows you all this surface model is connected. It's a nightmare. You don't know where the alignment is, what's going on. I have an alignment and I have a surface. So what I can do is I can highlight my surface either in the Project Explorer or directly in my plan view. I can right mouse click and go to my properties. In the properties, we can see now that this alignment is horizontal alignment. At the moment, it's specified as none. So what I can do, I can go into here. Wherever is blue in TBC, you can change this. I've specified this is an alignment-based model. Still nothing's happened because I said no. When I say yes, you'll now see the screen and it automatically knows that this is a surface alignment-based surface, and it takes off all those erroneous triangles outside of the model. It will also correct any issues that you have inside here for triangulation. So it knows that the alignment is base and everything else will be perpendicular to that alignment. Okay. Here's where I say densify. So when I say densify this model, I say yes. It's generating the model. So it goes through, looks at all the horizontal alignment, all of that vertical alignment, and checks, does that comparison, is it within my 3 millimeters tolerance or 5 millimeters tolerance, what we set up before. And now it's rebuilding it. Okay. So now you can see on the curves, there's a lot more information here to actually corrected the curves for those tolerances. Here's my tolerance of 3 millimeters. I could actually say, okay, I'm happy with 1 centimeter. When I say enter, it's going to regenerate. I have my settings set to auto generate. So as soon as I change it, anything in here, it will automatically recalculate the model. If this model is really big, then you might want to say, take that automate off, and then you manually say regenerate the model. And I can see that the templates have been removed or reduced to fit my 10 millimeters. So depending on what your tolerance is, then you can actually see it in here. Okay. I just want to do one more of the densification to show you an even better option. So I have actually got a design here. Got my plan view. I'm just going to take these values off. These are my line information. So what this was, 20 meter, it's the one you saw before. It's a 20 meter section, cross section data. We have existing cross sections or proposed cross sections. And you can see it's actually on a straight line. So what happened here is they had the cross section information before they actually got the horizontal alignment. So they put in a dummy alignment in here. That's just the dummy alignment, dummy HAL, and they can build the cross section model on that alignment. Later on, they actually received the true alignment. So I can just drag and drop that alignment into here. And there you see the curve that we had before. Now I want to select all of these templates or these cross-section information and assign them to this model, this alignment, sorry. So in my home option, I can go to selection, layer, and either click in the box or I say, okay, I want to have everything on that layer and everything on that layer. I don't want to have the alignment because it's not the true alignment. If I now right mouse click and go to properties, you can see here multiple layers because I've got two different layers, the existing and the design. And my horizontal alignment now should be DD6, not dummy alignment. So when I click on DD6, it automatically takes all that data off and assigns it to that correct alignment. I'll delete this. So now we have our cross sections. We haven't got a surface model yet. So what I can do, I can go into surfaces. I want to create a surface. I'm going to call this one design. So let's specify for design if I want to do any volume calculations later on. And here, my options, I can manually click, or again, I can go back and simply say by layer. Select that layer and say OK. Now, if we look in here, if I go to my view filter manager, I'll just take some of these layers off. So proposed cross sections and my design surface. So that's what we had. And there's my design that we come in. If I look at my 3D view now, you can see it's very corded in here. If you look underneath, we have a tight curve and we have a tight curve here. So again, I select my surface. I go to properties. I say it's an alignment based. Yes, it is. It hasn't corrected for that chording because that's the densification function, not just the road alignment function. So now I go back into here and I say, I want to densify. And now you'll see that was the original cross-section template that came in. And now we have nice curved lines coming in here and in here. So your design is now following the true geometry that we had before. Okay, so now you're happy with that. You can send that out to the field crews, off to the machine, and start building your road. Okay. And the last one I want to show you is this one. This one should start looking familiar to you. It might look different for this from the slides that we had before because I've not even done the South African coordinate system. But what we have here, again, we have an alignment. We have a surface in here. So I'm going to go to my properties. It's alignment based. And I want to densify this surface. Okay. Extra lines in here, and you can see the difference between what's being created with densification from the true geometry to what the actual template that was brought in. If you look in the center line, and there's the difference between the two. Stall cross section, and that's my center line, my alignment. Oh, sorry, that one. There's my alignment, and there's my stall center line. So under my corridors option, we could create corridors, but right at the far end, you'll see some corridor earthworks reports. So if you don't do volumes of your information, or here you want to do your roughness report. So I need to specify an alignment. So again, I can click on it here or graphically. What do you want to use? Well, I want to use my surface model. So it's selected the whole surface model. My fixed distance, my continuous overall, I want to do fixed distance and every 10 meters. I'm going to put in 1.7 as my threshold. And now I say, okay. So now comes up information on the presentation. You saw it had the South African coordinate system in here. It tells you your threshold. It tells you your IRI interval. If you use the next screen, next page, you get your listing. So now we've got every 10 meters in here, and you can see the red line is my threshold and the blue is my exceeding the tolerance. So IRI in certain areas it's higher, and now you can see change 40, 50, 60, 70 is high. If I go back and I can say, okay, for my alignment, show my profile view. If you look down here, you can see the chainage. So there you go. We're getting close to your chainage 40, where the first IRI value changed is the start of my vertical curve. There's start chainage 40, 50, 60, 70. So that's actually going through that vertical curve. The next one is the 110. Which is the start of the second vertical curve. And I go to the next screen. We have here 170, 180, and 200. So again, 170, 210. So there's some issues with these the designs on these vertical curves. So, and you can see that because it's outside of your IRI tolerance here, your IRI threshold. So you can go back to the design and say, can you check those vertical curves? What's going on? Because we don't think that's correct. Or you're willing to accept it, knowing that this IRI is outside of my threshold. Okay, and that's as simple as that. Really quick, simple. Bring different types of data models in, quick checking them, make sure it's okay. Do your IRI reporting, and then you can get all your results out from that as well. Okay.
And I think the value there is if your design, the IRI is not passing on your design, there's no way that it will pass if you build the road.
Afterwards,
so that's, yeah, afterwards there's no way it will pass.
If your design is outside of tolerance, then there's no way in hell you're gonna build your road within your tolerance. So it's a good way of checking first to make sure that your designs are correct. So even though we did the densification, it's still saying that, okay, I've improved the model, but I can't do magic. There is still some errors in here because all we did was densify the model. We didn't go in and create that model or recreate that model. You need to go in and check and find out what's going on. Okay.
Okay, perfect.
I've stopped sharing for now. But if there's any questions, we can go. I can jump back into TBC and show you. So that's no problem.
Yeah. I think, yeah, thank you very much, Dave, for that demonstration. Any questions we will handle now. If there's anything you want to ask, you can unmute yourself and ask the question directly to Dave. Yeah, thank you. Just going to check in chats. Maybe there's questions. No, I don't have anything in the chat.
Everybody's shy. Nobody wants to talk. That's why I preferred. I love to do this in real person to person, because then I can pick on people and make them ask questions.
Okay.
Jaco.
Yes, Kobus.
Yes. I hope you guys are doing well. Dave, I just want to find out if you get a error with your design, what is it usually attributed to?
It's normally the vertical curves. The vertical curves is wrong design or something in there, or depends. I mean, if you might, if they are building cross-section models, somebody might have keyed in the wrong elevation of the cross-section for that particular area. So you could go back but then the IRI would pick it up and say, between this station and that station, go in. That's one thing I didn't show you. Sorry. Yes. can I share again?
Yeah, I'll stop sharing.
Back into TVC. So we had this, if I just take that surface model off. So these are all templates, cross-section templates, stored cross-sections. If I want to check in and find out what's going on, I could actually click on one of those sections, go to edit. I'll just get rid of the grid lines. Some people like grid lines, I personally don't. So now it's interpolated that cross-section. It's given you your offsets from your center line, your elevation and what feature code it was, and you can actually step down. You can step down the changes and you can physically see if somebody's made a mistake. So if you do get an IRI issue, you can say, okay, I want to go down to change 100, 140, I think it was. So 140, cross-section looks good. So that means, okay, nobody's made an error here. I can then go back into the alignment and check what's going on the alignment. Maybe it's the vertical curve. It should be a vertical curve rather than a symmetrical vertical curve, or asymmetrical vertical curve, or one of the settings has been entered wrong. We can go in there and change that. Does that answer your question?
Yeah, I think it's more, I think, human error. If you get everything right, then it should be fine. Is there any way that you can do as-built on the existing road and pull them into TBC to check the IRIs?
Yes, so you can go off with a scanner. So you got a Trimble SX12 scanner, you can go off and scan the surface. You got a mobile mapping scanner, you can go and scan the surface, or third party, whatever it is. If you're doing asphalt, if you're using the roadworks, that actually, and the concrete paving, sorry, you could actually, when you're working, it saves .pav files. You can bring those files into TBC, and then you can run that IRI file across those as-built surfaces. You can then do all your volume calculations as well. So you can do your as-built against design, see what's going on, everything's okay. But generally is to run your IRI information.
Okay, thank you very much.
I hope that answers your question, I think.
Yeah, thanks.
Okay, any other questions?
If anybody's too shy, then you can send an email to Yaku afterwards and he can pass it on, or I can email, you can send by email, it's no problem at all. So yeah, if you have any questions and you don't want to speak up in front of people, I understand, there's no problem. We can ask it later.
Yeah, any questions can be sent to me. If you scan this, you've got all the details for Cytec. Bryce is also online. You can reach out directly to Bryce. But yeah, please, if there's anything, questions that you need answering, please reach out to us. Yeah, so if there's no further questions, firstly, I want to thank everybody for making time to join us today on the webinar. And thank you very much, Dave, for making time in your schedule as well to present. Yeah, that's it. Thank you very much, everybody, and have a great day. We will be contacting you afterwards, just for a chat, to find out what you've learned and if there's anything that was of interest for you. So yeah, expect our call, and yeah, thanks for your time and have a blessed day further.
Thank you.